This is Unit 3, Assignment number 4, the review. Feel free to fast forward, pause, rewind, whatever you may need. All right, in question number 1, we do have vertex form. First thing we need to do is give the transformations. For this particular one, the first transformation we'll come across is dealing with the +4 inside the parentheses. Remember, inside the parentheses, it always goes opposite of what we think it should. It's always the opposite side. So a +4 actually goes to the left 4. And then the -9 outside the parentheses does exactly what we think it should. It follows its sign, so a -9 does go down 9. So the transformations, they give us the directions of where to find our vertex. Our vertex goes left 4, so -4. Down 9 will be a -9. Axis of symmetry, don't lose out on easy points. Don't forget your x equals. The axis of symmetry is a vertical line, so we need the equation of a line, so we need the x equals. And remember, the x value for the axis of symmetry is the same as the x value at the vertex. Concave up or down. This graph does not reflect. We do not have a reflection for our transformation, so our graph will open up. Remember, we're talking about how the graph opens, not whether or not it moves up or down. The domain is always all real numbers. The range in this case will be a y. The graph opens up, so will be greater than or equal to, and it's always the y value at the vertex. Finding the x-intercepts, remember, to find x-intercepts, that means we put 0 in for the y, and we solve for the x. So in order to do this, we want to get the squared term by itself. So regular equation solving steps apply here. To undo subtraction, we're going to add 9 to both sides. Now all we have left on the right side is our squared term, x plus 4. That entire binomial is being squared. So to undo the square, we take the square root of both sides. Now remember, when that happens, the square root of 9, we could square +3 and get 9. We could also square -3 and get 9. So the square root of 9 could be +3, it could be -3. Yes, we do need both. Then to finish this, we just subtract 4. These are x-intercepts. I'm going to go ahead and finish finding the y-intercept, and then we'll put all of our pieces on our graph. So to find the y-intercept now, 0 goes in for x. So whichever intercept you want to find, 0 goes in for the other variable. Now this is something, if you want to just put it right into your calculator, you can. Every parenthesis, addition sign, exponent, whatever you see, goes right in your calculator, and we should get y equals 7. So now we go to graph these things. All you're graphing are a bunch of ordered pairs. So the vertex, that's the middle of my graph. In this case, we know the graph opens up, so it's my lowest point, my minimum point. So I graph the ordered pair, -4, -9. Axis of symmetry is the vertical line right through the vertex. Next, my x-intercepts. Again, they're just 2 ordered pairs. -1, 0 and -7, 0. Then the y-intercept, again, another ordered pair, 0, 7. Our graph is symmetric, so I can take the y-intercept. It's 1, 2, 3, 4 spaces away from the middle. Now I go on the left side, 1, 2, 3, 4 spaces away from the middle. And I go ahead and I draw on my graph. All right, same thing, moving on to question number 2. I'm going to pick out the transformations first. Picking out the transformations just helps us to know what our graph should look like, where it should be positioned at. Should it open up? Should it open down? Should it have any X-intercepts? It just helps us figure out what our graph should look like before we even graph. So when I go to give the transformations, the first thing I come across is a negative sign. Multiplying by a negative causes a vertical reflection. Then the 1/2, remember we look at that multiplier without the sign. So the 1/2 is smaller than 1. So it's going to cause a vertical, you could call it a compression, or a shrink. I know there's a mixture of what you guys like to call it. Either one's fine. The -2 inside the parentheses, again, it's a -2. It actually is opposite of what we think it should be, so it actually does go to the right 2. Last but not least, the +8 outside the parentheses, that sign does exactly what we think it should. It does go up 8. So there's our transformations. I've drawn arrows to each piece to show where that transformation comes from, how we know our graph does that specific thing. Then for our vertex, look to our transformations. Our transformations tell us to get to our vertex, we go right 2, and we go up 8. Right is a positive direction. 8 is also a positive direction. Axis of symmetry, again, don't forget the easy points of x equals. And it's always the x value at the vertex. This graph does reflect, so we're going to open down. Domain, always all reals. The range is always our y value. Our graph opens down, so all of our y's will be less than or equal to the y value at the vertex, which is 8. Our x-intercepts, again, to find the x-intercepts, 0 goes in for y. Now again, the squared binomial, the x minus 2 squared, I need to get that by itself first. So same as if we were solving an equation that just had x, no squared in it. We need to get that x by itself. So we need to get our squared term by itself. So we start by undoing addition and subtraction. So we're going to undo addition first by subtracting the 8. And I like to just keep drawing a box around that square piece. I know it doesn't make a square, kind of reminds me of a square. It's more of a rectangle. But that square needs to get by itself first before I can take the square root. The -1/2 out front, I cannot distribute that because of the exponent. So instead of multiplying the -1/2, I actually have to divide by -1/2. Be careful when you put that into your calculator. Make sure you put parentheses around the -1/2. Double check this in your calculator. If you're just copying down this video as I go through it, make sure you double check in your calculator. -8 divided by -1/2 should be 16. So try that out. If all you're doing is copying down as I'm going through, take a minute here, take a pause, make sure you can get that correct in your calculator. Now that square term's by itself, undo the square, we square root. Square root of 16 could be +4. It could also be -4. Add the 2. We get 6 equals x. Or -2 equals x. So our x-intercepts, I like to write them as ordered pairs, so I know exactly where to graph them. You might be a little bit out of space here. Last but not least, let's find our y-intercept. To find the y-intercept, 0 goes in for x. And again, you can go ahead and you can enter that. This is another one of those times if you're just copying down as I go through, this would be a nice time to pause and make sure that you can get that y equals 6. Now it's up to you. I know I wait, I fill in all the pieces, and then I put everything on my graph. If you want to put different pieces on your graph as you go, you sure can. Like as you find your vertex of 2, 8. If you wanted to graph that right away before you move on to the next part, you can. Axis of symmetry, x equals 2. X-intercepts are 6, 0, and negative 2, 0. Remember, if you fold your graph in half, the two sides should match. So if your x-intercepts aren't matching up, if you were to fold your graph in half on the axis of symmetry, then something's not quite right. Our y-intercept is 6. It's 2 away from the middle. So now on the right side, I go 2 away from the middle. So if I really want to double check myself, I go back to my transformations. Should have a vertical reflection, which means our graph should be upside down. It is. Vertical compression, our graph opens a little bit wider. It's decreasing a little bit more slowly. Our graph is shifted over to the right 2 and is shifted up 8. You could also enter that equation into your graphing calculator into the y equals. Press graph. Make sure the two match. All right, third and final question here on the front side. Start again with transformations. The 2 multiplier out front, 2 is bigger than 1, so we have a vertical stretch. There's no negative sign, so there's no reflection, just a stretch. Then inside those parentheses, we have a plus 3. Remember, a positive or a plus really goes to the left. It's always opposite. Now, this is one I've had a lot of questions when people go to do their vertex. The left 3, we've got that part. It's going to be a negative 3 for the x. But then some people are stuck. Miss Golly, there's no up or down. You're right. This graph doesn't move up or down. So the vertex has a 0 for the y. That's okay. Sometimes a graph doesn't move left or right, and there's going to be a 0 in the x spot. That's okay. Axis of symmetry, x equals the x value at the vertex. There's no reflection, so we open up. Remember, open up, not move up. Domain is all reals. The range is always y. We're opening up, so we're greater than or equal to the y value at the vertex, which is 0. To find x-intercepts, 0 goes in for y. Now this time I don't have anything to add or subtract. The only thing I have to worry about is the 2 that's out front. Remember, we cannot distribute because of the exponent outside our parentheses. So distributing would mean we'd multiply by 2. We can't multiply, so to undo that, we divide both sides by 2. 0 divided by 2, if you need to, double check it in your calculator. It does equal 0. And then I have x plus 3 squared. That squared term is by itself, so now to undo the square, I square root. The square root of 0 is just 0. I'm not going to do a positive 0 and a negative 0. 0 is just 0. So 0 equals x plus 3. Subtract 3. And in this case, I only have one x-intercept. If you only have one x-intercept, guys, it is your vertex. If there's only one x-intercept, it doesn't have a mirror image on the other side like our other x-intercepts did. And that's okay. It just means this graph touches the x-axis just in one place. So that means we have to graph our y-intercept to get more points. So to find the y-intercept, 0 goes in for x. So now again, if you need to, just pop that right into your calculator. And in this case, we get y equals 18. Please do not just try to extend your graph out. Change your scale. I'm going to change the y scale so it goes by 2s. So each box is just worth 2. So there's my 18. It's 1, 2, 3 away from the middle. So I go to the left, 1, 2, 3. Remember, the vertex is the middle of your graph, not the y-intercept. So that's the last question on the front side for this review. Again, feel free to rewind, pause, ask questions. Here we go to the back. All right, on the back side, we have our application questions. See if I can zoom this in here so I can, there we go, fit everything on there. All right, so we have the Wheelie Fast Company makes custom skateboards for professional riders. They model their profit with a given equation, where B is the number of skateboards they produce in thousands, and P is the company's profit in thousands of dollars. So we're going to treat it just like we did the ones on the front. We're going to find our transformations and all those other pieces so we can get a sketch of our graph. Then we're going to use our graph to answer some of the questions about the company's profits. So the transformations, the negative sign, vertical reflection. The 2, we're going to get a vertical stretch because it's bigger than 1. Minus 25, inside the parentheses, we're going to go right 25. Plus 450, on the outside, we're going to go up 450. Our vertex, we go right 25, up 450. Axis of symmetry, x equals, and it's 25. There is a reflection, so our graph is going to open down. The domain and range, we're going to have to wait on this. The domain and range are going to be a little bit different, given that this is an application situation, where our x value we're used to looking at for the domain is our number of skateboards. And our number of skateboards, we can't put in any number that we want there. So we're going to have to take a little closer look at that. So we can go ahead, though, and find our x-intercepts. We're going to put 0 in for y, which is actually p in this case. And instead of an x, we have a b. If it's more helpful to you to switch out the b for an x, you sure can. We need to get our squared term by itself, so we're going to start by subtracting 450 from both sides. We cannot distribute the -2, so to undo that multiplying, we're going to go ahead and divide by -2. So we get 225 equals b minus 25 squared. Squared term is by itself, so now I square root both sides. The square root of 225 is 15, could be positive 15, could be negative 15. Please make sure being able to find the square root is something you can also do on your calculator. So if you've never tried that, make sure you're taking a pause here, and please try to find that square root. When we get to these application ones, the numbers are going to be a little larger than they were on the front side, like finding the square root of 9 or the square root of 16. These are going to be some larger numbers, so make sure you know how to find that. Add 25 to both sides. 40 is one of our intercepts, and 10 is the other. Y-intercept, we put 0 in for, in this case it's a b, and we solve for p, or again, if you want to change that p to a y, I am fine with that. And we get p to be -800. All right, so let's go ahead and sketch our graph. When I ask you to sketch, guys, I'm not expecting you to put a scale on the graph. These are some larger numbers. We're going to spend more time trying to figure out a scale than we are actually applying the situation. So I'm going to start with graphing our x-intercepts. we have a 10, 0, so I'm going to go right about here. And then out here somewhere, we're going to have our 40, 0. The vertex is exactly halfway between these two. We're at 25, 450. Now the y-intercept of negative 800, P represents profit. So graphing a point at negative 800, it's not going to do us any good. So I'm going to go ahead and sketch this. And I'm going to go ahead and label. In this case, our x-axis is being represented with B. B is the number of skateboards. Number of skateboards. And then our y value in this case is P, and P is representing profit. And they're both in thousands. If you can squeeze that label in there, profit is in thousands, and so is skateboards. So now, let's do the application part. Up to this point, nothing new for us except for we labeled the axes. Where the different pieces go, how we find those different pieces, no different than what we did on the front side of this sheet. So now for letter I, it says how many boards do they need to produce to maximize their profit? Well, where are we going to find the maximum? The maximum is going to be up at our peak, up at our vertex. Now we have to decide though, is the 25 the number of boards or is the 450? So there's where our labels come in handy. The 25 is our x. Our x-axis says it's the number of boards. And then our 450 then is our y. Our y is our profit. So the maximum boards is 25. And it's in thousands, so I'm going to put 25,000. More properly, we should have boards on there. And then the maximum profit, that's up at that same vertex spot, and we have 450. Again, the labels should be 1,000. How many boards do they need to produce to break even, which would be a 0 profit? That happens at two places, 10, 0. And 40, 0. So 10,000 or 40,000. And again, we should have the label boards on there. What is the profit if they produce 15,000 boards? There's where we need to use our equation. 15 is the number of boards, which is our B value. So P equals negative 2. Instead of B, I put 15. And then I fill in the rest of the equation. Now that is something, guys, I'm going to throw right in my calculator. You can probably even hear me pressing the buttons. And I get 250. And we're going to throw the label 1,000 on there and that $sign. So again, don't let these application questions bother you. They're the same as the ones on the front. Where we put our vertex, how we find transformations, X-intercepts, all those things are the same. Label your graph. Label those ordered pairs just like I did with that vertex. It makes it so much easier. I'm not guessing at is the 25 the number of boards? Is it the maximum profit? What do those things mean? These questions are essentially the same as the three on the front. We're just putting labels on them. That's the only difference. Last but not least, question number 5. We're launching a rocket from a platform. Its height in meters, t seconds after launch, is modeled by the given equation. So let's go ahead and find the different pieces. If maybe you watched and let me walk you through all of question 4, maybe pause here, try question 5 yourself. Or at least maybe try letter A and then unpause it and check it. Pause and try the vertex. Make sure you're trying some of these things yourself as you go. All right, so for the transformations, the negative sign causes our vertical reflection. The 4 causes a vertical stretch. The -8 inside the parentheses, remember, inside is always opposite. So we're actually going to go right, which is a positive direction. The plus 400 means we're going to go up 400. Vertex right 8, positive 8. Up 400, so positive 400. Axis of symmetry is always x equals x value at the vertex. Concave up or down, we are reflecting, so we're going to open down. Domain and range, we're going to skip that and come back to it. And actually, that reminds me, I totally skipped it. Let me rewind here. Sorry, guys, I totally skipped it on the last one. The domain is always our x values, which in this case is the number of boards. Now, my number of boards, I don't want it to go below 10,000, and I don't want it to go above 40,000, because we know from part K that 10,000 causes us to break even, and so does 40,000. So in between those two numbers, the company is making money. If I go below 10 or above 40, the company loses money. So we wouldn't want that for the company. So for our domain, 10 would be the smallest number of boards we want to sell. You could use X or B there. And then 40 would be the largest number we would want. That would be for your domain. Now your range is your profit. The smallest profit, well, we really wouldn't want to go any less than 0. I kind of hesitate. You could put an equal to there. I probably wouldn't put an equal to if I were a company, but if you put it, I wouldn't count it wrong. This is our profit. Now the profit, we'd like to say is unlimited, but we found that our maximum profit, according to letter J, is 450,000. So when you do the domain and range for the application cases, you really have to put it into context. For this company, the domain is the number of boards that they're going to produce. If they produce anything less than 10, they're going to lose money. If they produce any more than the 40,000, they're going to lose money. For the profit, they want to make above $0, but what they found is 450,000 is their maximum. So just keep that in mind when doing the domain and range for the application. I always save it for last because these lower questions help me figure out that domain and range. All right. Back to question 5. That will let me scroll here. There we go. All right, back to question 5. So again, we're going to put the domain and range on hold until the end. Let's find our X-intercepts. We're going to put 0 in for H and solve for T. If you need to, rewrite the equation with a Y and an X. That's okay. I'm not going to mark that wrong. Undo our addition. Undo the multiplication. Again, we cannot distribute. We've seen that several times here today. We cannot distribute. We have to undo using division. Now we take the square root to undo the square. Could be positive 10. Could be negative 10. Let's go ahead and add our 8. We get an 18 for T. And we get a -2 for T. If you need to write those with X's, please feel free to do so. The Y-intercept, in this case, we're trying to find our height when our time is 0. Again, this is something I throw right into my calculator. And I get my height as 144. That's my Y-intercept. So now when we go to sketch, we have a -2. Sorry, I didn't get that line over there for you guys. So we have -2, 0. And then I'm going to go out here for 18, 0. Our vertex is right in between. We have 8, and we're up at 400. And then our Y-intercept this time, it is positive, and having positive height definitely makes sense in this context. So 144, I'm going to go right about here. Now, if you need to draw in that axis of symmetry to reflect that y-axis over, please feel free to do so. Now, I kind of didn't draw this side great. There we go. Now, if you want to connect it down, you can. Negative time doesn't make sense, but if you want that symmetric parabola, please go ahead and draw it all the way. I'm going to go ahead and label. X-axis in this case is represented by t, which is our time in seconds. And then our y-axis in this case is represented by h, and that's our height, and our height is in meters. So now that we have a sketch of our graph, let's go ahead and answer our lower questions. So far, guys, up to this point, the only thing kind of different for us compared to those front questions is I labeled the axes, and instead of x and y, we have h and t. But again, if you need to rewrite that with x and y, you sure can. So what is the maximum height of my rocket? I'm going to go to that maximum point on my graph, and I'm going to label. The 8 is my x value. X represents seconds. 400 is my y. Y is represented by height, which is our meters. So what's the maximum height? Is 400 meters. How long does it take to get to the maximum height? 8 seconds. Now letter K says how high is the platform? It says our rocket is launched at the platform. So that means it's on its platform when we're at 0 seconds. So when we're at 0 seconds, that's our Y-intercept. So the platform is 144 meters high. How long does it take the rocket to hit the ground? Here's where our height is back at 0, and that's at 18 seconds. Domain and range for this case. The domain, again, deals with our x values. Our x values in this case are our t, which is our time. Time cannot go lower than 0 seconds. And really, once the rocket gets back to the ground, we're not going to be timing it anymore. And it reaches the ground again at 18 seconds. That's our domain. For the range, again, the range deals with y. Y in this case represents the height. The height this time, we can actually, I know we started 144 meters, but it does go back down to the ground. However, the height, though, does not go any higher than the 400 meters. So again, this is when we reach the ground. This is our maximum. Time cannot go negative, and it's back on the ground in 18 seconds. So you just have to think about what range of values makes sense for each variable. So in the context of time, I can't have negative time, so we're not going to go any smaller than 0. And in this case, with a rocket launching, once it comes back to the ground after 18 seconds, we're going to quit timing it. For a height, it does eventually reach the ground, which is a height of 0, and it can't go any higher than 400. So think about the range of values that makes the most sense for that particular variable, whatever it happens to be. So that is it for our review. Again, feel free to go back, rewind, pause, ask questions, whatever you need.